Okay, so let's get started. So this week we'll be looking at some other basics of IT operations, and hopefully would cover them all before we now move directly into cloud. And as we begin to go through some of the cloud curriculum, we'll try as much as possible to relate it with what we had covered last week and this week, and see how that how they add up, how the understanding of the concepts here actually helps you in making maybe management, operational, or probably even design decisions when it comes to cloud. Because some of us may be opportune to make the decision to design and implement or probably deploy stuff within cloud, while some of us will be strictly just management of resources, services, instances that we have within the cloud environment. As the case may be, we'll see how that helps us. So first, we talked a little bit about networking last week. Would also talk a little bit more here. We look at IP, subnets. I believe it's basic what that I expect. The expectation is that a large number of us will be familiar with this concept, but nevertheless, we'll still look at it. We'll talk about routing. We'll talk about DNS. We talked about DNS a little bit last week. Then we'll talk about DHCP. Then we'll look at file and storage system, identity management. We'll look at public infrastructure, fault tolerance, availability. We'll talk about some basics of PowerShell. At a number of sessions, we'll be talking about PowerShell. So it's better we start with the basics to understand the basics of PowerShell. Then if time permits, then we'll just begin to fly our boats into the cloud. So first, we know what IP addresses are, I believe, and every now and then we understand that it is the backbone of every IT infrastructure, probably service. So there's no IT infrastructure service that you don't have to deal with IP address. And if our understanding of IP addresses is just the fact that yes, we assign IP addresses without having some other understanding behind the scene, then we may find it a little bit challenging when it has to do with fixing issues or probably even designing systems. So first, we have to understand that IP address is that means of identity within a network where you identify resources. And we are familiar with the concept of a class A, class B, a class C IP address, maybe a public IP address, a private IP address. I'll take that for granted that we know. And if we don't really understand that much, we can, what's it called, take time to check. And I would also share a number of resources after this. But of utmost importance to us here is IP address as related with defining networks, subnetworks, maxing, and also when it has to do with the CIDR notation. So during our basic, if we still recollect at some point in time when we are taking maybe it's basic of IP address, we are told that IP address is made up of 4 blocks of 8 bits each. And depending on how it is defined, some bits actually identify the network, while some bits identifies the client. So the network means a unique identity for the whole network generally, while the client basically means that that part defines what IP address a client or a resource on the network takes. So for instance, if I have something like 192.168. Let's say .10.0. This is my network ID for my network, saying that the first 3 blocks actually identifies my network. And since this last block is also made up of 8 bits, which allows us up to 2 raised to power 8 units, which is about 256. It means that this block can allow me identify about 255 or probably 254 as the case may be, knowing fully well that at some point you have to identify your broadcast. You have to identify your broadcast. You have to take out what would be your subnet max, and you have to take out your ID, which is start from 0. So I could have something like up to 1, up to 254 IP addresses. So I believe we know that. And what makes us know this is the traditional way of defining IP address, because you can see all I've defined is just the IP address, nothing more. But and nothing more, because by default, the thought process is that this is a Class C IP address, and the default subnet mask for Class C IP address is 255.255.255.0, where this subnet mask is a scheme that tells you that within this IP address, the first block are for your network, where the last block, where you have 0, is for your host. So, however, it might not always be this way on networks or probably on devices. And why it is important is that when you have a node or probably resource on the network where you have an IP address, you don't take it for granted that because I'm seeing 192.168, it is the default Class C IP address, and the max is going to be 255 or 255, or probably it's going to be a /24, as the case may be. You don't take it for granted. You'd have what's it called to check, because it might actually change. In some cases, it might be lucky that's the default point. In some cases, it can actually what's it called change. And the reason why it changes most times is because you have organizations trying to use the CIDR notation that allows them to optimize block of IP address. We understand that concept of saying your what's it called, Class C IP address is for small network, your Class B IP address is for medium network, your Class C IP address is for large network, but small, large, medium can be relative. So in some cases, 255 host is a small network, while in some cases, 255 is actually a large network. That would even require them to begin to break it down. So how do they make use of this CIDR? So the CIDR, simply put, is you specifying your IP address in the / notation, but not just in the / notation, but also trying to optimize that IP address by picking up bits here and there to make it up. For instance, let's say by default, we know this is a Class C IP address, which is /24 by default. And that /24 gives me up to 254 allowable hosts. But like I said, this 255, being small is relative. For my organization, it could be large. And I want to break it down, further break it down. I don't want to go into another block of IP address entirely, like maybe a Class B, because Class B is even larger than Class C. So if I say this 255 is large for me, and I now choose to begin to go to a Class C, or probably even use another block of Class B, it's still being too large. So I may want to begin to manage this IP address. Then I begin to toil with some of the bits. Mind you, I had said this guy here, this last 0 here, is a usable 8-bit. A usable 8-bit that you can play with to define more parts to be your network and less parts to be your, what's it called, host. So if you are doing CIDR notation and I do /24, it means that the whole of this bits is actually for my host. But if I go ahead to do a /25, what does that mean? That means that I'm taking an additional bit from here to add to the existing 8 block here, because what this 24 means, so that we know, is 8-bit first block, 8-bit second block, 8-bit third block, naturally it should also be 8-bit port block. So an IP address is made up of these 4 blocks of 8 bits, which makes 32. But if you had used the first 24 for your network, you are left with 8 bits for your host. So, and this 8 plus 8 plus 8 gives me 24. But if I say I come here to use 1 more bit for my network, I now have 24 bits, which reduces the amount of bits I have for host. And due to the fact that these bits are in power of 2, all these allowable hosts are in multiples of 2. So what that means is that if I do a /25, what that means is that I'm dividing this my allowable host into 2. So /25, where this last block naturally is 256. I said this is 254 because you have to pick out certain hosts, but the actual IP addresses is 256. If I divide it by 2, I have 128, which is /24. I mean /25. If I go ahead to say I do /26, what it means is that I'm dividing this further into 2. If I divide 128 divided by 2, that should give me like 64. If I go ahead to do a /27, I'm breaking this down into 32. If I go ahead to do /28, I'm saying this guy is now 16. That's the idea behind using CIDR to optimize your network. So simply put, in reality, what that means is that if I have the need to design a network and I need to subnet, so the first thing, so that I don't assume we know, the reason why you subnet is to segment your networks. So if I have a very large office building, let's say for instance, I have finance here, I have let's say operations here, I have IT here. They could be under the same network such that resources on the finance floor or network be accessible by IT and they'll be accessible across each platform. But for security reasons, it might be necessary that I disallow that. If you're on the finance network, you can't access resources on the IT network. If you're on the ops network, you can't access resources on the IT network. How do I do that? I break this network. So if the whole of this is 254, a 254 network, that is class C IP address because I'm a small organization. A class C IP address, but I still want this layer of security. So this is what's it called? Security comes into play for those of us that have picked interest in security. Your network segmentation, in some cases, you see part of maybe your defense in-depth model might come across that along the line also, where you have to put several layers. One of those layers of security you can put, what's it called, at the very basic level, is doing network segmentation. Divide your network so that they are not accessible across each other. So, and this is a small office with just 254 allowable hosts. So, and I want to break this down. So I can break this down flat across to say, okay, I have these 3 buildings. Maybe I have 20 users here, I have 30 users here, I have, let's say, 60 users here, and I have this block of IP address. What can I do? Then I'll look at my 254 block, which is one single block of class C IP address. Then I'll say, okay, if I do a /25, then I'll have 2 networks of 128 each. That's not what I want. If I do a /26, I would have 4 networks of 64 each. This makes sense. Even though I would have a sphere of 64. So I would say, okay, I give this guy 64, I give this guy 64, I give this guy 64. What would now be the block of IP addresses? These guys will be 192.168. Let's say my block of IP address is .1.0. So this guy starts with .1.0. starts from .1 to 0 and ends at .63. Because at .64 is the beginning of another block. So this guy will now be, the next block will be 192.168.1.64. And this guy will end at 64, that is 127. And the third guy will now start at 192.168.1.128 and stop at, I believe this should be 192. Now, if you see in an environment where you have this segmentation, you won't find a host computer system with this IP, with this 192.168.1.28. If subnetting or private segmentation has been done, you won't find, using this block, you won't find the computer system with this IP address. But in an environment where this segmentation is not done, you would find a computer system with this IP address. So when there's a need for you to use an IP address and you're not the custodian of the IP address scheme, you don't go ahead and assume that 192.168 192.168.1.128 is a usable IP address, except maybe you validate from the network admin and you are told that you can go ahead and use it. That's also one of the importance of knowing this. They would also get to appreciate that more when it comes to defining networks within Azure, because within Azure, primarily, your networking is primarily built on top of this, because at that level, proper management of IP address is key and very important, because if you get it wrong at the very beginning, it might be difficult for you to begin to change and modify a lot of things you have set up and it's already working. So that is the idea. But this is one approach where I could break my class, CIP address into 4 blocks, but I have 3 buildings and I use equal sizes of 64, 64, 64 for them, and I would have a single block left. But I may also want to optimize further based on the fact that that 64 block is too much for finance and ops, because finance has just 22 users while ops has got 20 users. So which means a 32 would most likely work for them. So if if IT, which is the largest, maybe because they have a lot of network appliances so they are within their network, they do a .64, which is by default that is a /26. They do /26. Let me change this stuff. 2 seconds. So let's assume IT is doing /26. It's not necessary that we'll do /26 for the next guys. If we do /27 is 32. We can come and do /27 for these guys. I can come here to do /27. I can come here to do /27. So which means I am allocating a 32 block here, a 32 block IP address here, and a 64-bit IP address here. So within the same scheme, I have 2 different subnet, type, or probably subnet max. This guy is /26, this guy is /27, this guy is /27. And what that means is that if IT starts with
Sorry, sir.
Yes.
I just want to ask a question. For the IT, I just need your knowledge on it anyway. For the IT, don't forget that we have the network and the broadcast IP that needs to be put in place. That means that you only have 2 available IPs. What are some situations whereby you need to, maybe some new members join IT, and you need to now assign IP address to them? Let's say 3 or 4 more new staffs join IT. What will now happen in that kind of situation? Are you going to now do the CIDR all over again, or you just move from 64 to another bit?
Okay, so that's good. So if now I said, how many people did I say is in IT? 60, right?
And
okay,
you have your network and broadcast as well, making 62.
Thank you. Which is a very good question. So which means that if I go ahead and use /26, I would now be left with just 2 usable IP address. And if for any reason we just had about 4 people joining the team and they will be on IT, or maybe we onboarded 4 network appliances and they'll be on the IT network, then we are stuck. We have just 2 IP addresses, left. If I had designed my my network that way, such that, so I'll come back to that. So let me just complete this. So if based on this design, or probably based on this instance, IT would have this, right, from 0 to 64, which is /26.
Yes, sir.
And I had said finance would have /27.
27, which is 32.
Yeah, so this guy will now start, from 60, that is 65. If I
Yes,
do
sir.
plus 32, that will give me one, this is 32, this is 7, this is 197, right?
Yes, sir.
So then I go again to do /27 again, /27, which is for ops. I'll just need to add 32 to this guy. Now you can see that the IP address now is in sequence. So which means I've used up the first 64 units of IP address and moved to the next 32. So which means when I need to expand this of IT, there is no room for me because the next block, which is in sequence, is already used, right?
Yes, for finance.
For finance. So what I could do that way, and if I want to use consequent, the blocks in sequence, it means that I have to move finance out of this block and move them, which is a whole lot of work. What I could do is, instead of changing these 2, then I would rather change just that one block. Although the best would have been that when you are designing your network, you give a room, depending on what model, probably scheme you are looking for. Some would say you give a plus or minus of 10%. Some would say 20. But you have to be able to project what would be the pattern of increase. But remember, some devices will go, some will come, but you want to create a buffer. So if I'm going to create a buffer based on that at present, what I have is 60, but I want to create a buffer, then for that IT block, I could do a /25. That gives me 128. That is at the inception, at the design stage. I would have put that into consideration. But let's assume I didn't put, which means that was my mistake. Then I could now do that /28 at the bottom. So if I do, if I have, following this sequence, let's say 127, 160. So this one would be, let me put that here. Looking at this subnet max here, this guy would be /0. This guy would be /20. This one would be /24. This guy is 25. This guy is 26. I'm actually mapping this table so that we know. So this one is 24, 25, 26. This guy is 27. This guy is 28.
28.
This guy is 29.
29. 30.
/30. Sometimes you don't get to use this 31, 32 because naturally you have just 1 or 2 IP addresses and your network will take one, your subnet, your broadcast, would take one. So what I would now do is look at from the bottom of that IP address. So if it is a /25, a /24, and I started from 1, so presently IT is using 1 to 64. I've given out the next up to 197 plus 32 is what? 197 plus 32 is what? This is 9.
224.
224, right?
Yes.
224. So, and I have 255. Oh, so yeah.
Hello, sir.
Yeah,
Hello,
I can
sir.
hear you.
Sorry for interrupting. Because when I did this network security, we used to do all these manual calculations, but there's a site on IP routing that does the subnetting for you. All you just have to do is just to put input in, so you don't need to be doing all these calculations.
Which is perfect. Yeah, there are a lot of resources where you just need to put in your key and it gives you
also.
exactly. Thank you for bringing that up, which I would have also come to that naturally you don't need to do all this, but the challenge is that you need to understand how it's done, or probably the metrics, the mechanism behind it.
Yes.
You can go online and purge. Instead of me doing all this calculation, like she said, I could just go and identify the next block. But what I'm trying to drive at here is that I could come and start from the next block. I could come and start from the next block. So, sorry, let me change this back. So I'd currently use the 464. I've used the next 32. I've used the next 32, which means currently in use is a total. This is 4 plus 4. This is 8. This is 6 plus 6, 128. And you know, in the block of class C, I have 255. So which means I have another unused 128. I could come and just IT to this next 128. So which means at that point, the network ID of IT will now start at 192.168.1.128, where this is network ID, and end at 255 or 254, as the case may be. But the challenge with that now would be that you have to begin to update the IP on each of your appliances. So which means the best bet for you is to have considered that during your design stage, so that you don't run out of the what's it called IP addresses. So instead of now doing all this design, some people could just decide to use that. I can't be giving myself headache. I will just go ahead and do a 255, 255, 255 for IT, 255 for finance, 255 for, let's say, operation. So I'll do 192.168.1.0 for IT, .2.0 for finance, .3.0 for operation. Which gives them 255. I say at least even till what's it called, the last day. At this rate, we might not exhaust them. That is also fine if it is allowable. But this is the traditional way, the way it is done traditionally. But
okay, so sorry, sir. This is what I'm trying to see if you are going to head to this way, because I could remember during my previous workplace, we had this issue because we want to segment each floor according to their IP. So if there is an issue, we know where it's coming from without we having to, because we have different floor of different IT equipment. So at the end of the day, we end up coming this route, because I could remember when we were doing that segmenting or doing the /120/64/2627, it became an issue. So this thing that you just put now, the different network 1.0, 2.0, 3.0, happens to be what we ended up using at the end of the day.
Yeah, it's a shortcut. But so let me put it this way. If you are using it within the private IP address system, naturally it will just be, I wouldn't say it's an over design, because you know there are best practices. If you have wealth, it's more or less like if I have a river behind me, why do I need to buy bucket and container to save water? Makes no sense, right?
Yes, sir.
At least, we may say it makes no sense, but for somebody who wants to manage stuff, instead of, irrespective of how much the resources are, they'll still go ahead and buy those containers and choose to begin to fill the containers and use from the container than going to take from the, what's it called? But design best practices are you'd manage and you plan for IT scheme. But if you see in this part of the world, let's say the largest corporation you could have in Nigeria presently, the largest number of workforce, let's say maybe an MTN, for instance. I don't know their number, but I'm just assuming. So let's assume they have over say 16,000 workforce. There may be more than that, and with over 16,000 endpoints. So you know, naturally, they have no business with class C IP address.
Yes, sir.
I believe we know that, right?
Yes, sir.
And for a class, sorry, they have no business with class C. For a class B, which is 255 times 255, they're already getting close to 16,000 plus,
Exactly.
if not over. So they will just go ahead and do a class A. And even if they have restriction is class A, you know, you have subnetting, you have subnetting. Even you could begin to bundle up two different blocks. For instance, you could bundle up two blocks of, and how you do that, so just to give us an idea, you know, here we are talking about breaking down network into smaller network, into smaller chunks. It could be the other way around, which you call supernetting. So
what did you call it
just to give
again?
us an supernetting.
Supernetting.
Yeah. And the way that works is I have a class C IP address that gives me 255 or 254. Let me consistent and say 254. Let's say a 1.0. I have another 254, a 2.0, right? There are two different, by default, based on the scheme of those IP addresses, there are two different networks with two different subnets, and both of them will take a subnet of /24/24, right? Or if it is in the traditional way, it will be a subnet of 255 on the third block. But if I want to mumble these together, all together, combine them together, what I'll do is use it as a /23. I'm going a step backwards. /23 combines these two together and gives me 254 plus 254 IP addresses. So for MTN at that particular level, they may say, oh, class A is still very large for us, but instead, let's begin to combine two class B IP addresses together. That is still part of their planning. Else, they could as well just say, let's just go and use class A like that. There's no problem in that, especially when there are internal resources.
Sorry, sir. If
but
I understand,
when it comes to public, yeah, go ahead.
So if to continue, I just want to understand Supernet. I've never heard it before, right? This is my first time of hearing it. But
yeah, sure.
I think if you are combining like two classes of IP together, is that what it means to Supernet? I just want to get that.
Yes. Because two blocks of the same class. Two blocks of the same class. You can
because you were going 23, 22 earlier. That means you are doing two different blocks of IP together. That's like class A and class B.
So you're getting it mixed up. No, you're getting it mixed up. So the default for class A is /8, right?
Yes, sir.
Default for class B is 16.
Yes.
Default plus class C is 24.
24, yes.
If you are breaking 24, this class C down into smaller subnets, this guy will continue to increase in this direction.
Yes.
Which means you are subnetting, right?
Yes.
Subnetting being, I'm breaking it down into smaller networks. I'll go this way. But if I am combining, I am supernetting, combining two class C IP addresses to give me a larger block, I'm going upwards, which means I'm supernetting. So instead of /24, I would have /23.
Okay. And that also increases the numbers of available IPs.
Exactly. So /23 for two blocks of IP address would now be 254 times 2. /22, yeah, will be 254 times 4.
Okay.
You get it?
Yes, sir.
That is what's it called, because you don't want to go directly and begin to use a class B. You still want to stay within the range. So if I combine two IP addresses, two blocks of IP addresses from class C, my first, and let's assume my IP address is .0. The first one with .0, the second one is 2.0, which means my IP address will now start from 1 up to 2.254.
Okay, sir.
Do you understand?
Yes, sir.
So which means 2.1 becomes a usable IP address even within the scheme of my IP addresses, and they'll be within the same network instead of being in different network. And at that point in time, if you are looking at the traditional, what's it called, the traditional way, what you now have as the subnet max will be 255.255. Okay, 255.255.255.0, which is the traditional one. Instead,
Yes.
it's now be 255.255.A252 as a subnet max, meaning you have taken out of this bit here for supernetting. If it is for subnetting, you are taking out of this one here. It's just reversing the trend.
Okay, sir.
So that's the idea. So, like I said, the importance of understanding this, even though we know that we can always go to a site to punch what you are, either you want to combine, break the boundary of a class of IP address to supernet, or probably you want to subnet and break for that. You can just go ahead and punch in what you want online, get your block of IP address. But it's important that you understand. And one of the most important things when it comes to understanding that you are looking at is what the subnet max is, either in the traditional way of 255.255.255 or in the traditional way of a slash, because you don't just go ahead and assume. For instance, if I have a 192.168. let's say a .10.5 under a slash, say a slash 25, this IP address would not be able to reach a 10. Let's say 250. We know why. Did you get my question?
So can you come again, sir?
No, come again, sir.
So let me just rub this off. A second. So if I have done subnetting and one, let me use screen, and one PC1 picks up an IP address of 192.168.10, let's say say 52. That's the IP address of PC1. And I have another PC2. And this is slash 25. I have another IP address of 192.168.10. Let's say a 201, also slash 25. They won't be able to reach each other.
Sorry, sir. They are still within the same.
They are still within the same network.
They are not.
I believe the usable IP there on network should be 512, and if you look at the subnet, it's still the same.
Check the subnet. This is slash 25.
Yes.
Slash 25 is 256 divided by 2.
128.
So the first block is from 0 to 128, which is one subnet. The next subnet is from 129 exactly to 254.
Yes, they are in the different network.
Exactly. This guy falls in the second block, while this guy falls on the first block. For them to be able to reach each other, you have to make them routable. You have to define routing path for both of them. So that means there must be a router between or a routing device between both blocks to take packets from this block to the next block. That is, you have just done segmentation. Because by default, when you segment using subnetting, both blocks won't be routable. They won't be able to reach each other. So if I get on a network and I just see a .5, a .52, and I do see a .201, and I didn't check the subnet max, and I just assume that they should be reachable, and users are complaining that I can't reach this, then you just be on a wide goose chase. You'll be looking for what is not missing. Because sometimes when we are entering subnet mask, a number of us make mistake. I want to do maybe a 255, I mistakenly do a 253, or maybe I do a 254, or probably even I do a 0. You know, some of those mistakes, and you don't get to know. And you are done, you feel like, oh, I've done it. Then for you to have what's it called, reachability across, there's now a challenge. Then you begin to troubleshoot. What's the problem? Is it firewall? Is it this? Is it that? Until you go back and check what subnet you defined. So it's important for us to, what's it called, know that. And that takes us to routing. And basically, what routing means is that you are making networks, two networks reachable. Let me rub this off. So I want to make two networks reachable. So I have one network here, I have another one here, I have another one here. And they are, even if they are on the same physical, maybe they are connected physically to the same network, which would probably be a wrong design, because depending on your design, for your physical switch, you could do VLAN, but they'll be connected to the same physical switch, but each port is assigned to a different VLAN. But that is what's it called, behind the scene, which might not necessarily be what you do. But your expectation is that they'll be able to reach each other. For them to be able to reach each other, then you must be able to provide an intermediary, especially when there are a different network between them. That is where you have a router, or you have a switch that can also, a layer 3 switch that can also perform the function of a router. So, what it does is just tell the guys on this network that if you want to reach, this is network A, this is network B, and this is network C. If you want to reach network A, go through this path. So the way it works is that you always define what you refer to as maybe a routing path, a route, or a default gateway. You could define both at the time. Your default gateway, what it means is that if there's any packet within this network that is not destined for this network, send it to this guy. So if this guy is let's say a 5.1, and this guy is a 6.7, this guy is a 9.8. The computer system here, which is a 5.1, wants to send packet to this computer system here in B. When it sends that packet to the switch at that particular layer, what it does is to check, oh, are we within the same subnet? If we are not in the same subnet, then the question is, what should I do? That question of what should I do is defined by the route within that network or by the default gateway. So naturally, by default, it sends it to the router. The router would also be connected to that network, and it will have an IP address. The IP address of the router or the routing device is what you refer to as the default gateway within the network. So if you go to a network and you see default gateway, that default gateway is the IP address of either the router or a device that is functioning as a router on that network. And what that default gateway will do is that any packet that is not for this network, that is outside the network scope for this network, is sent to the router. It is now the router's own responsibility to decide on how to get that packet to the destination. If it is not a default gateway, you could define a different routing path. For instance, situations where you do that is if I have a default gateway and I have this, so let's assume there is no, let's assume there is, okay, so yeah, let's assume there's this router here, no problem. So my default gateway is the IP address of this router here, and I'm saying any packet going outside of this network, if you don't know the destination, send it to this default gateway. However, I have this link here that can reach 9.8. I could define a manual route to say, if the destination is 9.8, instead of sending it to the default gateway here, just send it directly to this link. That is you defining a route, what's it called, path. And you could do that directly on your host devices. You could as well do that directly on your router that is using any of these routing protocols. For us, some of us have done what's it called, network, maybe OSPF, EIGRP, or probably IRP version 2, whatever routing protocol. That is what you use on the router. On your host device, you'd have a routing command that would allow you to manually add a route. And sometimes you can modify it, you can change it. What's it called? Let me see if I can bring up my system, my CMD, to show us that routing. So a number of times, let me, okay, so let me, before I bring up my console to show us, let me give us a scenario where you'd sometimes need to do that. You need to do that a lot number of times when you are working within the Azure, but within the traditional, within the Azure environment. But within the traditional environment, you can, on the Windows Server environment, you have the routing and remote access service. And one of those things the routing and remote access service does is to allow you use a Windows Server as a VPN gateway, as a VPN server. So which means if people want to, so this is the server, this is my network. The server would have two legs. It will connect to two networks. This is the local network, which is your LAN. And this is your external network, which will be most likely a public IP address or a IP address behind a NAT. So we know what VPN does. VPN allows you to, through the internet, this is the internet. Here I am here with my PC. I want to connect to this local network. Naturally, your local network are not accessible on the internet. You either have to go physically and connect your system to that network, either Wi-Fi or probably a cable, or you do VPN. If you do VPN, you are connecting across the internet. That tunnels your traffic, send it to this guy, and this guy gives you connection to this guy. That's the way VPN works. So when you can't specify two default gateway on the same network interface card, else you confuse the server. I hope you are getting what I'm saying. If you have more than one adapter on a system, part of the parameters of IP address you specify is your IP, your subnet mask, and your default gateway. So if I have this guy connected to two different networks and I have two different default gateways, the server becomes confused because the default function of default gateway is under any situation. When you have a packet and you don't know where to send it to the default gateway. But now you have two default gateways. The confusion will now be, who do I send it to? So that's why only one of them is required to have a default gateway. And a large number of times, it is the one that is connected externally to the public IP address that should have a default gateway. So, but when users now connect to your VPN, right, and this guy should be able to route packets. So I have a server here, maybe a web server here. Let's call it the intranet. I do www.myintranet.com. On this computer system, after connecting to VPN, I do www.myintranet.com. It resolves to a private IP address, which my VPN server would have assigned to me, and it takes it in here. But how does this server knows that you should take that IP, that you should route that packet in here and not send it to the default gateway. I have to manually specify a route. So if the block of my IP address on this, my local network is, let's say 192.168.1.0, I have to specify to say if any packet as the destination network as this, route it to this interface. So this interface can take it home. So how do you do that? Let me, few seconds, stop sharing this screen. Let me share another screen. Yeah, my console. Yeah. So I have my console here. So you have this route command on the Windows environment. Now, you could also have it on the Linux environment as well, because both of them actually, there are situations where you have what you have on the Windows, you also have it on, what's it called, Linux. But this guy says, just description, okay, no description, but just parameters. So by default, what do you need to specify a route? You need the command route. You need the max. You need the gateway. You might include metric if we understand routing protocol, we know what metric is. Metric, you use metric to define which path to take. If you have more than one path to a particular destination, use metric to do that. And you have the interface, which is the adapter, if the computer system has got more than one adapter. So if I need to add a route to a particular path, this is what I need to do. I just need to do, say, route add. I specify the destination, which is the network. I specify the network max, and I specify the gateway. And I specify the interface that has this gateway. So what this is saying is that if there's a packet that is destined for this network, and the network has this max, please send it to this guy. And if there are more than one path, use the one. So now this is me just specifying the metric for this, but the way the system makes that decision, if I had added, let's say, 3 of these, one has metric 1, one has metric 2, one has metric 3, it will use the one with the least metric in there. That is what this does. Let me see if I currently have.
Sorry, I want to ask a question.
Yes.
Like, I think when it comes to like this route that you just showed us, is it not that the shortest path should take place? Like the metric shouldn't is the metric not what is meant to like supersede all those ones? Because I believe that when you have different routes in table and you want to get to a particular destination, it's meant to be the shortest path. Don't forget that speed also matters to get to your destination. I don't know if that counts.
Yeah, we are saying the same thing. So you are saying it should use the shortest path.
Yes.
But you are the one deciding which one is the shortest path. So if I have 3 routes now, so let me put it this way. Let's assume I have route 1 for 157, still the same network, 157.0. 7.0.0, 0.0.0. Route 1 is to go to 157.55, which is one gateway.
Yes, sir.
Yeah, let me even stop at 55. Route 2 is to send it to another gateway that is 58.
Okay.
Route 3 is to send it another gateway that is 67.1. I, the administrator, know which is the fastest, right?
Yes, sir.
When I'm now adding the route, if this one is the fastest, when it gets to the metric part, I'll give you metric 1.
Okay, sir.
The second fastest is the maybe .88. I'll give you metric 2. Now, this is you manually defining the route and the decision for taking the route. And this is on your local host, but on a router, where the primary function of the router is to do that, we are using a dynamic routing protocol. Where the dynamic routing protocol.
Hello.
Yeah, go ahead. Yeah, I can hear you.
What's the distance between the metric and administrative distance?
So when you are using a dynamic routing protocol, that is when you are having administrative distance, the shortest path first, and all those stuffs.
Okay.
This is your host. This is not a router.
Oh, okay.
This is your Windows computer system. So you are on the Windows computer system, you are manually defining the route.
Right. Okay.
Yeah, exactly. And you have to manually specify how it makes the decision. But on a router, you have those dynamic routing protocols, OSPF, EIGRP, exactly, BGP. And each of those routing protocols have got methods by which they define the path. It could be the shortest path. It could be the, what's it called? The distance. It could be the weight. Exactly. That is for a router. But here, we are manually defining what's it called? It. So what's the importance of this? Now, number one, in twofold, when it comes to working within Azure, there are instances where you have to manually define a route a lot of time, especially when you have several subnets within Azure, or probably when you have an hybrid. And the sort of where should this traffic go? Is it meant to go to the internet? Should it remain within Azure, or probably should it go to my private network, which is on premise? You do that. And also in instances where you need to troubleshoot in situations, maybe on a computer system, a user has, for instance, if I do ipconfig /all now, this is my network. My default gateway is this, right? .1. If a user, maybe by mistake, has gone to manually add a route, and if I come here to say route print here, this is my route table. This is for version 6. And if you come here, you see destination max. We know what this means. If you have destination 0.00, that, thank you, that's default, so our default gateway. So you are saying anything default, and you can see it as the lowest metric here. This is currently my routing table. If through a malware or installation of certain applications, maybe you are toiling around to labs looking at your system, you are doing VMware, stuff like that, and it basically just toys with your routing table, and it changes your default gateway. Let's assume it changes my default gateway to, this is 100. This is .1, which is the IP address of my internet modem. The IP address of my internet modem is acting as my router now. So any traffic going anywhere, it goes to the modem routes it to the internet. But someone goes and changes it to .5, where .5 is not even an ID, an IP address that exists. I'll continue to try to access the internet. It will be bouncing back, right?
Sure.
Because, yeah, that gateway does not exist. And you'll be, oh, is it my router? Oh, is it that I don't have data? Is it that the user is not connected to proper network? Is something wrong with the network and stuff like that? Except you come here to print the route table to see that this guy has changed, and you manually change it before you can get, what's it called, that fixed. So that's important. But the way it is added differs. But this scheme here, I do route. This scheme here is just gives you an idea of how it is done within this environment. But the same concept also, if you want to add route on Azure also, you have to know your destination, you have to know your marks, you have to know your gateway, you also have to define a metric. But how you combine this within the command, if you are using shell to add it on Azure, or probably within the portal, might be different. But the most important is that when you're adding a route, you have to know your destination, which is the network ID for the network you are routing for, the marks of that network, the destination interface or the gateway where that network will be sent to, In some instance, within what's it called Azure, it could be what's it called, a gateway. It could be a network appliance. It could be the internet. It could also be an interface, a network what's it called, interface adapter that you had created. And you may also specify the metric. So that's that for routing. Going back to the slide. So now DHCP, DNS. DHCP is a network serving dynamic host configuration protocol. Yeah, and what it does is to assign IP address automatically for you. And you have that a lot by default. You have DHCP service working within Azure by default. That's why if you spin up a VM, it automatically has an IP address. You don't go ahead to assign those IP address because what drives that is a service that does that. But you could also locally, there are instances where locally within the environment, you also use DHCP service. And some switches comes with DHCP service, some router comes with DHCP service, and also on your Windows server, you can as well install DHCP. And what are the things that you need to know about DHCP? Primarily, you need to know about scope. And you need to know about lease. Your scope is the pool of IP address from which DHCP can pick up IP and assign. While your lease is the duration for which a client can use that IP address. So irrespective of DHCP service I'm using or probably application, if I say my scope is 192.168.0.1, let's say .1 to .200. What it means is that I have a pool of 200 IP addresses from which DHCP can pick randomly and assign. Then my lease, if I now define my lease as 7, what it means that the client that has gotten an IP address has it for 7 days. Depending on which of the DHCP service you are using, you would always have a renewal period. It could be 3 days, it could be 2 days. What that means is that if the lease period is 7 days, at the 5th day, the client should begin to negotiate for a release if he wants to use it again for the next 7 days. If he does not negotiate for a release at the 7th day, that IP address would be assumed as not being used by that client. And if there's another client that needs an IP address, it will give out that same IP address to that client. I hope we are getting it. Hello?
Yes, sir.
Yes,
Yeah,
sir. Sure.
so that's the basic and most important thing that you need to understand with what's it called, DHCP. That there's a scope and there's a lease duration and the period of time for which that IP address is being leased. Now, you could have a lot of issues that may come up within stuff like that. Maybe a client computer system has gotten an IP address, he's using it for just 1 day and it's gone off the network. That IP address is still tied to that computer system, even if it's not on network. So some of the design decision that comes into DHCP is how long should be your lease duration? Should it be long? Should it be short? If you are in an environment where you don't have a lot of mobile users, I can choose to specify my lease period for, let's say, 100 days. Because the computer system is a desktop computer system and the next 100 days is not going anywhere. But if it is an environment where a lot of those devices are mobile, that means someone can be in the office for just 30 minutes, connect, and get an IP address. If my lease period is 100 days, that IP address will not be usable again for another person until the next 100 days, even though that device that got it is on the network for just 30 minutes. So which means in that situation, you would be having problems of IP addresses. Oh, DHCP is not giving out IP addresses again. And if you now see the list of IP address that is currently on that list, a lot of those devices are not on the network again. So you have to now, depending on what type of DHCP, service you use, you have to now go and purge them or probably delete them from the Windows Server environment or probably console. It's possible for you to go and pause and delete. Would after this, I would set up a DHCP service and DNS service on Windows Server. I would see how it works, but I'm not just going to activate it because so that is now the reason why I said, can someone just guess the reason why I said I'm not going to activate it? Especially for the guys, for the security guys here. Any idea?
Activating it may alter your current settings in your system, I guess.
Yeah. Yep. So you have so it's in twofold. Me being the administrator of the environment, yeah, activating it would alter a lot of stuff because I already have an environment where there's a DHCP server that is giving out IP address. And now I'm going to put up another DHCP server to give out IP addresses. It's going to cause confusion. If the IP addresses are within the same scope, you begin to have issues of duplicate IP addresses. If they are on different scope, not on the same, subnet, you need to have cross-communication issues. That's one. On the security side of it, where it is not me, the administrator, you have the concept of rogue DHCP. Somebody introducing rogue DHCP on your network causes a lot of disruption. Number one, it could lead to hijacking, access to legitimate clients. It could also result to disruption of service, kind of denial of service. So because now your client's computer system, which are legitimate clients on your system, are coming to my own rogue DHCP server to get an IP address. And mind you, it is not just IP address alone that you can give to a client through DHCP.
DNS server.
Thank you, default gateway. And also some other custom informations that you can define within your scope options. So it means I'll be giving that client computer system a rogue default gateway. Any traffic that client computer system is generating will be sent to a router on that I have control, and I can have a sniffer on that router. Number two, it gives me connectivity access to that client because it is now within my own network. That is when you have an intruder doing it. But if it's a mistake on the side of the administrator, it's just going to cause disruption, which you can always, because you know what you've done, you can always, figure it out and take it off. So that's the idea behind the DHCP. Then you have DNS. We talked about DNS the last time. We didn't see. So I expect that a large number of us would probably basically know how it works, but we'll still go ahead and see how it works within the Windows Server environment. But before we do that, I'd explained in the last session that your DNS helps you with domain to IP address name mapping. Domain to IP address. And I said this domain name is a family name, which is a logical grouping for resources, computer systems, or probably hosts that belong to the same name system, the same namespace. Let me use that word. It's actually to the same namespace, where a namespace is something like rajaadewale.com. That is a namespace. rajaadewale.com, or in short, let me say raju.com, is a namespace. Anything can come before it. This anything that come before it will be the host name of any device on the network. So if my domain is raju.com, I can have host1.raju.com, host2.raju.com, host3.raju.com, and the likes. And it could also be standard names that depicts what type of service that host is running, with something like www.raju.com, ftp.raju.com. It's not like it is a must. I explained that last slide. It's not a must that I name my website www.raju.com. It's just a standard so that people know that, oh, this is a website. ftp.raju.com, oh, this is an FTP server. And what's it called? The likes. So when you have this logical name, what DNS does for you is to maintain a register. That register can be a database where what you have in the register is the list of IP to name mapping. And this list of IP to name mapping is what you refer to as records. Records. And you could have different types of records. Of most important and common is your A record, which maps your name to your IP address. Or the quadruple A record, which maps your name to an IPv6 IP address. But apart from these two primary records, you also have other records like CNAME records. CNAME is the same thing as alias. And what does it allow you to do? It allows you to address the same host by more than one name. So the same computer system, I can call it host1.raji.com. I can call it www.raji.com. It's the same computer system with the same IP address, but I'm calling it by two names. So that's why I have a CNAME record. And a CNAME record is the name to name mapping, name to name. So that means if I have, let me clean this off. So if I have a computer system with IP address 192.168.10.1. So let me get on instances where you have CNAME record. The name, the host name of this computer system, when I mean host name, that means the name that you assign to the computer system when you set it up, such that if you do host, if you type the command host name on your computer system, that name that it comes out with, sometimes it's called the NetBIOS name within the Windows environment. Host name for this computer system can be a random, sometimes it's always a random string, depending on what is your naming scheme within your environment. Let me call this server1.lagos or server1_lagos.raji.com. Writing is poor. So let me server1-lagos.raji.com. And it has the IP address of 192.168.10.1. On DNS, I would go and create, because I don't want to begin to remember this guy. Like, I don't even like remembering IP address. Once I know the name, I know I'm fine. So I would create a Hey record that would map server1.lagos.raji.com to 192.168.10.1. Now, on this server, what I want to install on it is IIS, Internet Information Service, which you remember from the last class, because it's going to be a web server and it's going to host my website. If it's going to host my website and I need people to be able to access it as www.raji.com, there are two ways to it. I can still go ahead and create a Hey record and call it www.raji.com and still point it to 192.168.1. Or I create a CNAME record. If I create a CNAME, that's why I said a CNAME is name to name mapping. I am saying that I'll create a CNAME record for www.raji.com, but pointing to server1.lagos.raji.com. So when people go online, what they type is www.raji.com. But behind the scene, there are two levels of resolution going on. First, www.raji.com is resolved to server1.lagos.raji.com. Then the second level is server1.lagos.raji.com is now resolved to the IP address. Why do you
Okay, like a two-factor authentication.
And not necessarily two-factor authentication, just
Like it's two-level.
Level of exactly
Two-level.
of name resolution. But why would you want to do this as against doing an A record? Sometimes if the IP address changes, I only need to update it once. If the IP address changes, I only need to update the IP address of server1. What's it called? Lagos.raj.com. I update the IP address and I'm fine. I don't need to come and touch the CNAME record. But if I'm using 2A records, it means I have to change the IP address in 2 places. I have to change it here and also have to change it here. That's just what's it called. So, and moreover, I can have more than one alias. I can have unlimited number of alias for the same server. If I do the same thing to go and have unlimited amount of A record, it means that when the IP address changes, I have to change it 100 times. So there you have CNAME record. There's also service record, SVR record. Service record is used in so many instances. Of one instance of significant nodes is within Active Directory, where you use service record to identify services within your domain. And like I said in the last class, that Active Directory depends on DNS, but DNS doesn't depend on Active Directory. So which means that without DNS, you can't have Active Directory. Why? Because how does your client computer system know which server is a domain controller? Maybe when you want to authenticate or do any other thing, it uses service record. What your client does is to broadcast, to say, and it does that broadcast to DNS. Hello, is there any LDAP server here? Then the DNS goes to check its record. Service record is a mapping of service to name. CNAME record is a map of alias or name to name. A record is a mapping of name to IP. Service record, service to name. So when I say service, you have services like LDAP, Kerberos. What other service? These 2 primary services are used by Active Directory. Then there used to be one other service I can't remember. If you use Sky for Business or probably Link locally also, it uses that also to locate your communication server. I can't remember the name of that particular service, but let's go with LDAP and Kerberos. So at this service record, okay, another one is Global Catalog. These 3 services are used within the Active Directory environment. So you have the Global Catalog. These are services that when the client computer system needs to use those services, it gets the server rendering that service through DHCP by doing what's it called? A shout out to DHCP through DNS. By doing a shout out to DNS to say who is offering this particular service. Then DNS will now go and check its register or the database and make it to look at each of those records one after the other, specifically the service record, because that's a service request. Then it will say, oh, LDAP. Okay, I have an LDAP. That LDAP is mapped to dc1.contoso.com. Like that's why I say it is service to name mapping. dc1.contoso.com. So the DNS server now goes back to the client to say, hi guy, I got an LDAP service for you and it's being offered by dc1.contoso.com. It gives the client dc1.contoso.com. But the client will come back to say, dc1.contoso.com. Oh, I don't know what this means. Can you help me with the IP address? Then it goes back to send another request to DNS to say, please get me the IP address for this. Then DNS comes back to check its A record this time around to say, what is the IP address for dc1.contoso.com? Just like it's a 2-level resolution for CNAME, it is also a 2-level resolution for service. So you could have service record as well. Could have text records we could use to add extra information, like maybe you want to specify what your SPF. Probably when we talk about, if we had the opportunity to talk about email systems and how you define email records, you could have SPF and the likes of them like that, DMARC. You could use text record. But one of the most common, the most common records that you have will be your quadruple A, your service record, your CNAME record. And then also you could have your MX record as well, mail exchange record. That is also when you have an email system. And this MX record is, okay, I will call it, say, a service to IP mapping. Service to IP mapping in the sense that it specifies which of your server is a mail server, is an email server. So when you go to so that's one bit. The second bit is the fact that you could have private DNS. I could have public DNS. Private DNS, which is a DNS that is responsible for name resolution within your local network. Or maybe your local private domain, because some domain, you could have local domain and also have public domain. Local domain, the domain is local within your network, it is not routable. Public domain, the domain is routable publicly. Let's take, for instance, some of us that might have had the opportunity to work within maybe an Active Directory environment. Your Active Directory domain may be something like, let's say, gtbank.local.com. Or sorry, gtbank.local. Not most times there'll be no .com, because that means you have two levels of domain. So it should have gtbank.local as your Active Directory. gtbank.local is not routable, it's not a public domain. So which means the DNS server would remain locally on the gtbank network. Then you now have the gtbank.com, which is routable, which is public. They could tie that to their domain, to their email and several other services that needs a public domain. So you could have a private DNS and you could have a public DNS. Your private DNS, you manage that yourself. Maybe using Windows Server DNS, you could have, what's it called? Bind, which is a DNS service on the Linux environment. For public DNS, you either have a DNS server that you host publicly, give it a public IP address, or you use the DNS service of public domain provider, maybe a GoDaddy or probably, what's it called? A Namecheap. But what you define, the way you define stuffs on them are the same thing. You define A record, you define MX record, you define service record, you define quadruple A records. That's what's it called. So just for us to know that you could find environments where the local and the external domain are not the same. And when they are not the same, it means that they would have two different DNS, what's it called, service, or probably they would manage their DNS on different ends, as the case may be. Now, when you, like I said, that DNS depends, Active Directory depends so much on DNS. Anybody who has an idea of why that would be? Especially if you are familiar with Active Directory. Yes, why so much depends on DNS?
Yeah, because it uses name resolution a lot.
Yeah, that's correct. It uses name resolution. And the reason why it uses name resolution is that everything within Active Directory has an identity. Everything within Active Directory has an identity. And that identity is tied to your family name, which is your logic name. Like I said, there may be gtbank.com, raji.com. That is the logical name. So I want to be able to identify everything with that logical name. And I still want people to be able to access them or probably use them using friendly names. Then I have to so much rely on DNS. That is why if your DNS service is faulty, or probably has issues, very likely your Active Directory will also have issues. So we'll come back to look at that. So that is that for DNS. Now, let me quickly just do a short demo of what this looks like within the Windows Server environment. And mind you, like I said, these are standard services. If you are not working within Windows Server environment, the way it looks might be different, or the way, but they all work the same way. The DHCP service on your switch, or probably on your router, or probably on a Linux server would also require that you define a scope and a list, and sometimes options, just the same way it will ask you on DHCP or Windows Server. Your DNS on bind or probably on GoDaddy would ask you to define records, either a record, CNAME record, service record, MS record, and it is just you providing the right name, the right alias, or probably the right IP address, and it's still the same way you do it on the, what's it called, DNS. So the most important is to understand how it works. Then when you find yourself in an environment where the technology differs, the understanding, the concept, methodology still remains the same. So just a few seconds. Any question while okay, start. If you have questions, let me bring up my virtual machine.
I have a question, please.
Yeah, go ahead.
Question.
Yes.
Concerning the hosting of the VM, the Windows Server on the VM. My question is, when you host it on the system, how can you use it to control systems that are in other branches of a firm?
I didn't get that. Can you?
I want to use my Windows Server.
Yes.
At the head office to control systems at the other branches.
Windows Server at the head office control systems at other branches. Although that is still not explicitly clear, but let me try to see if I catch or probably understand what you are trying to say. So okay. You have
let me re-explain.
Okay.
For instance, I have an experience using this server to control system within an office. Okay, systems that are just like 20 systems. But now, when you're not being given the task to use it to control system out at other branches other than that same location, how will you do that?
So to put context, you naturally don't use Windows Server to control systems.
Okay.
So what you are using would naturally be maybe a particular service or applications, and now depends on what type of control. For instance, Active Directory, yeah. So for instance, Active Directory, yeah, you'd use it to manage identity within the system. Something like SCCM, use it to manage configurations, what's it called, patch across systems. So that could be some level of control. But when you're talking about Active Directory, there's nothing extra special that you need to do. All that is needed is have those branches linked up by the network across each other. So I have let's say a Lagos branch. Okay, let's take for instance. Okay, I don't want to name any organization, so let me just say you have an organization that has the head office here in Lagos. Probably maybe they started out here in Lagos. They have their domain controllers here in Lagos, and the only network is this just Lagos network. And you have client contact systems, several other servers. The devices join the domain. You do your management of device, do management of users and stuff like that. Now they're extending to have a branch in Port Harcourt. Now it makes no sense if it's the same company to set up a separate network in silo there in Port Harcourt. All they need to do is to set up a network there and link it to Lagos, either through VPN or probably through a WAN link. We makes the that breaks the physical boundary between both locations. So the devices over there can still speak to the domain controller here. They can still access resources here. The devices here can still speak to the resources over there. Even if they need to extend it to as far as, let's say, Dubai, all they need also is still a VPN link between Dubai and Lagos. Exactly. But there could also be some other additional design twists to it, like in order to reduce what's it called, service response time. You could also give them a domain controller there in Port Harcourt, but that domain controller is not working in silo. It is a domain controller that is linked to your domain controller here in Lagos, because you could have more than one domain controller and they would communicate to each other, so that when the link between Port Harcourt and Lagos is broken and someone needs to authenticate, authentication would not fail. Because if someone in Port Harcourt needs to authenticate, when the link between Lagos and Lagos, the link between Port Harcourt and Lagos is broken or probably has issues, that person would have issues authenticating, because the authentication request is coming from Port Harcourt going to Lagos. So you can give them a domain controller there. You can add another different twist. Instead of giving them a read-write domain controller, you could give them a read-only domain controller, where the function of that read-only domain controller is that they don't need an administrator there. They won't be able to change anything. They won't be able to add user and remove user, make changes to the object. All they just need to do is read-only. The person, if they have an administrator there, the person can view and the client can authenticate against it. That's all. That is taking it to another, what's it called, level. So that's the way it works. You just need to break the boundary using network links across them, and they'll be fine. So you have my Windows. You have my Windows server already installed. If I want to make this guy a DNS or probably a DHCP service, now DNS and DHCP. Someone had asked last session that can you have multiple rows on the server? Yes. And one of those rows that I can have together on the same server is DHCP and DNS. They can be on the same server. So, and I can add more than one role at a time. Instead of adding DHCP first, then come back. So now you can see this. I even thought I'll be able to go ahead. Okay, yeah, let me say I should be able to say continue, since it's just a warning. It's not an error.
Sorry, sir. I just have a question.
Yeah, go ahead.
So I want to ask, like this Azure of a thing, is it possible for me to deploy a server on Azure and use it for Active Directory services and DNS for multiple branches?
Absolutely, it's possible.
And also, I can remember during my classes with you then, Windows Server, is there a way in Azure that you can deploy a group policy object?
Okay. So there are two ways to it, which we'll still come back to. There are three ways by which you could consume Active Directory in the cloud. First way, you go through the infrastructure as a service. That means you spin up a VM, just like we just did now.
Yes, sir.
Install Active Directory Domain Services role. So that means you have your server in Azure and you control it.
So how do I connect it to the workstations in other various branches?
You use what's it called, VPN or probably. So now let me clear this concept. Networks can extend beyond physical boundaries or probably physical limitations. All that is needed is just a link, and that is where the concept of your WAN comes in. And you have several WAN technology. You could have fiber link, you could have radio links, linking two networks, two different physical locations together. Or in the worst situation, use the public WAN. The public WAN is the internet. And the way you could use the internet is through VPN. So Azure itself is consider it a location on its own somewhere, because naturally, what's the cloud? Is your infrastructure on someone else's own computer system or on someone else's own data center? So if you use a managed data center, you have these co-location services. Some of us will be familiar with the likes of Main1, MTN, Rack Center that provides co-location services. What is co-location service? You don't have a data center in your own building. We have a data center built for you, provide power, provide cooling, provide security. Just bring your server and put it there. So when you put your server there, how do you now access it from your office? They give you a link. They give you a one link. And it does the same thing with Azure. You are putting your infrastructure on someone's own data center, which now they tell you is cloud because you can't see it. And if you want to connect that cloud to your own local network here, give it VPN. Is that clear?
Yes, sir.
Yeah. So if you have your domain controller, then cloud, and you have your local network here, and client computer system needs to consume it, you'd have to establish an hybrid network, an hybrid link, which is connecting your Azure data center to your physical data center or private server here in Lagos or private wherever it is, using VPN or using express route, which is another method, which we'll still talk about. Express route, we'll talk about VPN when we go deep down into what's it called, Azure itself. So for this is showing me a warning because naturally, and like I said, it was also raised, I believe it was also raised last what's it called class. It is standard practice that your servers always get a static IP address. It's standard practice, and that's why this guy is warning me. But now I'm not what's it called? I'll just ignore it because I can't control that now. So I'll go ahead also and add DNS. I can add both of them at the same time. This is also still a warning. I'll go next, next, and install. So doing this makes this guy. So this gives this guy makes it a DHCP server and also makes it a DNS server. And this should be done in a few seconds.
Give me that cake. Hold the cake. I'm not business owner.
So this guy is done. I'll click on close. So from here on the WinServer environment, you have this management console where you have the list of all your tools. So yeah, I can see DHCP, which launches the management console for managing DHCP. I can see DNS, which launches the console for managing DNS. So I'll start with DHCP. So yeah, I have DHCP. I can see this random name given to my server, right? So this is some of those random names I said that the default, and I'd mentioned that it's either your host name, is that called your host name, or it is called your NetBIOS name. Okay, yeah, it's even called, it's actually server. So this is giving me some kind of fictitious or probably behind the scene domain name. So that's why I have it at server1.cloudapp.net, but it's not my domain name. It's just what's it called? A temporary domain name that is used within the Azure platform. So you could, the primary things I said you'll be doing within DHCP is defining scope, list, and probably options. And you can do that for IP version 4 address, IP version 6 address as well, if what you are giving out are IP version 4 address and IP version 6 address. And the first thing you start with is I'll come here to say I want a new scope. Go next. I'll give this guy a name. Let's say Lagos, just any random name. So here I have to specify my range, which is my scope. So if I say 192.168.10. Let's say 1 to 192.168.10 to let's say 100. That means that I have 100 IP addresses in my pool. And you can see here, it is giving me the subnet max as per what is the default here. But if this is not my subnet max, I have to change it. So you can say I've changed it to 25, and the subnet path for 25 is now .128. So which means for this, what I'll have in this pool is from 1 up to 127 IP addresses. So I have 127 IP addresses here, which is, let me come here to say 127. Let me even see if this guy would help me. If I say 200, let's see if it would help me. And I'll go next. So it has changed it to 128. Did you see that?
Yes, sir.
It says, do you want to create a super scope that contains 2 scopes
Yes,
in
sir.
128 each? Yeah, because it's saying that I specified a /25, but yeah, I'm putting 200. This 200 is in the second scope. So it's not asking me, do I want to create 2 scopes? But no, what I want is just 1 scope. So naturally, if this is 1 scope, I'll stop at, let's say, maybe a 127, or probably, let's say, maybe a 120, so that I have 2, what's it called? So you can see that next page is gone off. So that guy was sensitive enough. So now within your scope, okay, I skipped this. You could also have what you refer to as exclusion. So what is exclusion? Currently, I said my scope starts from 100 to 120. So that means it can randomly pick between 100 and 120. But maybe there are certain IP addresses within this 100 to 120 that I want to use as static IP address to certain devices. And I don't want DHCP to control those IP addresses. Then I can specify them here. I can specify individual IP addresses, or probably I can specify a range. So if I come here to say 192.168 dot, what did I use here? I use .10. 192.168, let's say .10. Let's say from .50 to 192.168.10 to let's say .55. I want to use these IP addresses as what's it called?
Static.
Maybe
Static.
exactly, maybe as static. I don't want them to be in that range. So exclusion address or range of it that are not distributed to the servers. So I'll put them here. There's also an option where you also specify exclusion. Basically, I mean, what's it called? Reservation. Reservation is when you want a particular IP address to always go to a particular computer system, so that we don't get confused. There are 2 different things. I have exclusion, I have reservation. Exclusion, I have a range of IP addresses that are excluded from my scope. Reservation, it is not excluded from the scope, but it is reserved for a particular client. And how do you know what client it is reserved for? You have to know the MAC address of the client. I hope that's clear.
Sure.
Yes, sir.
Yeah.
Right, please, I have a question. So for some of servers that you know that you don't want DHCP to auto-assign or change their IP address, is it okay to then assign this static to them or exclude them at the point of this creation?
Yes, there are 2 ways to it. I give the whole pool. I have 200 usable IP addresses, right? One option would be, option 1, to be give all the 200 to DHCP. Give all the 200 to DHCP, then exclude the chunk that will go to servers as static, right? Option 2 will be take out a chunk from the pool and give the rest to DHCP pool. And how do I mean? I have 192.168.10.1 to 200. Instead of giving me this whole, giving this whole 1.1.200 to DHCP and now do an exclusion, I could as well just give 192.168.10.50 to 200 to DHCP, so that I can use 192.168.10.1 to 50 as static. Is that clear?
Yes, sir.
Yes.
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 Yeah, so it's what's it called? It's just those two options. Either give the whole pool to DHCP, then from DHCP exclude the one I want to use as static for my server, or I only give the one that will be used dynamically to DHCP, then I use the rest as static. Because since this guy is not in the pool, DHCP will never assign it. DHCP will start assigning at 50. So I can manually use this one myself as static. Or I give it the whole, because I still want DHCP to manage the whole pool, but I'm excluding a chunk within it to use as static. So that's the, so this is where I talk about the lease period or the lease duration. The default here is 8. I can increase it, I can reduce it. But you have to take into consideration if your network is highly mobile or probably highly stable or static. If it is stable, you can use long periods, like 8 days is fair. But if it is mobile, where people, for instance, maybe where you're offering free Wi-Fi, that people can connect, maybe their passerbys, they can connect within a short period, maybe at train station, and they disconnect. You want to reduce this to even 2 hours, maybe say 2 hours, 3 hours, so that your IP address doesn't get exhausted. Because if I have 200 in this pool now, and 200 people connect now, and my lease period is 8 days, those IP addresses will not be usable until the 8th day. So which means, despite the fact that those 200 people are not on the network, DHCP will not assign any IP address again, because you tell you that, where do you want me to get IP address? You asked me to give 200 to people for 8 days. I've given them for 8 days. Come back on the 8th day or 9th day, then you get IP address. But if you reduce it to, let's say, 30 minutes, every 30 minutes, the IP addresses will be refreshed. So which means even if the client is going to be on the network for longer than 30 minutes, at the, maybe depending on when is the, what's it called, the refresh, what's it called, interval, private refresh duration, maybe at the 25th minute, the client can go and negotiate for another 30 minutes, which is fine. So I'll leave this at the default. Then here, configuring options, I said your IP address, your DHCP doesn't just give out IP addresses alone. You can give it extra information to give out. And some of those other informations you can give out is your default gateway. You can give your default gateway to give out, your DNS server. You can give it your DNS server to give out, and several others like your wins. I don't know why they still have wins. Wins used to be before you add DNS. It's actually a whole protocol. No, not, you can't find it, what's it called, in use. Then this is where I said I can create it, but I would activate, because this environment itself currently uses DHCP. So I'll say I don't want to activate it. I'll go and say finish. So the scope will be there. You can see that red tick. That red tick means it's not activated. I'll leave it. I won't activate it. And here I can see what is my pool of IP address. I have from 1 to 120. I've excluded from 50 to 55. If there are devices that have currently been leased IP address, you see their list here. So in a situation where you are running out of IP address because it's currently exhausted and your lease duration is long, but you know some devices are no longer on the network, you can see all the devices that have leased IP addresses here, and you can just delete them. If you delete them, the IP address becomes what's called available. And I've spoken about reservation. Reservation is when you want a client computer system to always get an IP address, the same IP address all the time. Mind you, a reserved IP address is still in the pool. It is in the pool. But you are saying that if Mr. A comes all the time, just reserve that IP address for him, give him that IP address. And the way you do that is for a device that already has the IP address listed here, you just right click on it and you say reserve. Once you click on it and say reserve, it comes here, because here the IP address of the MAC address of every client that got an IP address is known. It's always most likely tied under what's it called, this unique ID. And you could also do that under version 6 as well. And there are several other, like these options that you have here, these options, you can either define it at the scope level or at the server level. So if I configure it at the server level, it means that all scopes, this is my router, my time server, the network time server, you also specify. So these are several informations that you can give out to the client when they are getting an IP address. It's more than just your DNS name server, probably time router, and so on, the default gateway. So if I specify this at the server level, it means that this would apply to all the scopes. So if I have 10 scopes here, because you could have more than one scope, I can go ahead and create another one. If you have more than one scope, then these options would always apply to them when they give out IP address. Then you have a number of, these are new features within DHCP Windows Server, or Windows Server environment, I guess starting from 12, where you can actually create policies, more or less like using conditions to decide which IP address scope a user gets an IP address from. So that's DHCP. If you come to DNS, if I come here to say DNS, here.
Can you hear me, Raj?
Yeah, sure, go ahead.
Oh, okay. So I have a question. Previously, when you were discussing the lease period, and you said if you have a highly mobile network where people move. So for some reason, I have a highly mobile network, and I choose to probably keep my lease period for 30 to 35 minutes. If I have a device on the network within that 30 to 35 minutes, or even post that, it renegotiates for a new IP. Well, within that process, does it disconnect off the network and reconnect, or what is the activity that happens on the device itself?
Yeah, good. It doesn't disconnect because the renegotiation starts before the 30th minute. So
Okay, before the time elapsed.
Exactly. So if I have a device, if I have specified 30 minutes, and the device is going to be on the network for, well, since the device is, so most times I don't know what percentage, I can't remember except I checked. So let's assume, let's just take catch, say it does that at 25 minutes. So at 25 minutes, it starts communicating to DHCP server to say, I want this IP address, or I want an IP address again for another 30 minutes.
Requests.
Exactly. So it gets, since the device is on the network, and the DHCP server, the IP address is currently linked to that same device, most likely it will get the same IP address for the next 30 minutes again. And when it gets to the point of 25 minutes again, if the device is still there beyond 1 hour, it still gets it. So it still gets the IP address. The only issue is that it means that you have too many frequent requests coming to your DHCP, what's it called, server. But what about if, so it makes several trials to communicate to DHCP server. It tries the first time. For instance, you might have instances where maybe the DHCP server is currently overwhelmed and is not responding, or probably something has gone wrong. It keeps trying until it's 30 minutes. If at 30 minutes, it still doesn't get an IP address, it will check if there's another DHCP server on the network. If there's still no any other DHCP server on the network, it switches to that default IP address that is called the API IP address, which is not routable. So, but what about if the device wasn't on the network? Let's assume it was on the network at 20 minutes, it got off the network, right? It got off the network, and up to the 30th minute, it wasn't on the network, and the DHCP server had assigned the IP address to someone else. At 31 minutes, the guy came back on the network. At that point in time, the IP address is not its own. automatically the first thing that happens is that a request is now sent to DHCP server to say, I want an IP address. Because on the DHCP server's own record, that IP address is now assigned to someone else. That client will not be able to use that IP address. So it would have to send another request for a renewal to get an IP address. And you, on your own case as an admin, you can also force an IP release or probably refresh. Before we come back to DNS, let me show us this. Try to increase font size of this guy to, let's say 18. Good. So if I do ipconfig /all, let me start with this. You can see from here, it says DHCP enabled, first information, lease obtained. When was this lease obtained? When will this lease expire? This is how many days? You got it on June 25. 7 days. So, and this is the address of the DHCP server. Then this client for DHCP version 6, it would have a unique ID saying that this DHCP client, this is unique, the unique, what's it called, ID. So now, what about if I want to force a release or probably a refresh of this guy? It's not yet 7 days. Today is not August 1st. Maybe for whatever reason, I want to force a release or probably a refresh. You have these guys. Renew version 6, renew version 4, release version this. So now, when you say renew, you are saying the same IP address, renew it. When you say release, it means that release, give me a new IP address. But now, if you are getting a new IP address or not, depends on the availability of a new IP address, an IP address that has not been leased out. But if you are saying renew, you are always saying extend. That means you forcing the renewal. So if I come here and run this command, let's see if it would honor that command, because this is I don't have control over the DHCP server on this network. This is Azure, but let's give it a try. If I say renew, okay, so let's go ahead now and see. This is 10.5. Let's see what we had there currently. We had 10.5, and the list was June 25. Let's see what we have now. Config /all. Yeah, still giving me, what is it called? June 25, because even it's not the current one is not expired. So let's now try release. How this would have no impact on this guy. Yeah. Now I just shot myself on the leg. You can see. What does happen? Any idea?
You try to renew the IP address.
Yeah, it's giving me a new IP address. And since I'm connecting using a particular IP address, I got disconnected. Shall you catch it?
Yes.
So that's it. It's going to, because what I'm asking for was a release. Give me another release if it's available. Apparently, it's available, and I got knocked off. So which means I have to go and reconnect to that particular server. So just a few seconds. So that's just the idea behind.
Raj, I have a question.
Yeah.
Can I go?
Right, please. Yeah, sure, please.
Yeah, I just want to find out what is the minimum what's the minimum time you can use, right? You used an example of 30 minutes earlier. Can it be lower than that? And if yes, how low?
Yeah, it can be lower. You can see that time. Is it 30 minutes? I would have to confirm. You could see the timing was in days, hours, minutes. So you can specify it in that, yeah, exactly in that format. I guess that should be towards the lowest that is available within that particular option console.
Okay, thanks.
Let me reconnect.
Please, I have a question.
Go ahead, please.
Most of those terms that you are sending to us on our email to learn the concepts, I've not seen majority of its use on this Windows Server training that we're having.
Like, give me one example.
Like a container versus
containerization.
Yeah, we'll come to that.
Containerization.
Yeah, we'll come to
some of them
and
know like
virtualization.
Public key infrastructure.
Yeah, we'll talk about public infrastructure here now. In this lesson, we'll talk about it.
I think I missed the class at the earlier.
Yeah, availability and clustering and yeah, clustering and load balancing. We'll talk about it here now also. So we'll talk about them all.
Okay.
Server
because I want to see as we implement it on the server.
Yeah. Okay, this guy is still trying to come. Okay, so let me just shut down that guy or probably restart it. Restart. Okay, so let's just continue with the slide while that guy is coming up. Okay, so file and storage. This is pretty straightforward. We have primarily we have two types of file system, storage system. You have directly attached, which we all know, your hard disk drive on your system, hard disk drive on your servers are directly attached storage. And there could be maybe any type. There could be SSD, there could be HDD, there could be SATA, there could be what's the name of this other protocol we use, method, this ribbon-like connector. I've forgotten. So, but those are the common methods you find on the devices. There could be PCI, yeah, or NVMe. Now, of most important to us is the network attached storage, NAS. Network attached storage. Oh, I missed that one also. There's NAS, there's SAN. Your network attached storage storage, the actual storage blocks basically, but the major difference between network attached storage and how do I give this example? So for network attached storage, they are your network. They are targets for you to place documents. So it's just like you having imagine that you have a cloud storage. I don't want to say a file storage as the case may be, but you have this NAS storage that when you put them together, they give you pool of storage which you could access as file storage. So you could access them as a folder, or probably or even as a network mapped drive. So yeah, that's the right word. Mapped drive across the network. They are that common. Basically, that common depends on use, but they are not heavily being used within the enterprise environment, just like your DAS, that is for personal use on your system. A large number of NAS can be for personal use. Maybe you want to have a backup system somewhere. You don't want to use a cloud. You could have a NAS box. Most of them come with between two to four storage slots. You buy storage devices, fix them up, connect them across the network, and you see that those storage as a pool where you can put your files and the likes. Then you have SAN, storage area network. For this SAN, what you have are a chunk of block storage. They are breaking down into further chunks and assigning to a server to also use as a block. Now, for NAS, you have block storage that you assign for use as a file storage. The NAS itself is a block storage, but you're accessing it across the network on a computer system to be used as a file storage. For a SAN, it's a block storage, but you're assigning it to a device as a block storage. So what is the difference between block storage and a file storage? Block storage is something that your system sees as an hard disk drive. It sees it as an hard disk drive. File storage is what your system sees, something like a folder. It sees it as a folder. Your map drive also appears in your system as a folder or a mapped drive. Still using that word. It appears like a map drive, such that if you open it, what you see there directly are what's it called? Your folders. So that is your file storage. Now, the importance of this here is that within current enterprise system, what you see most likely, what you find most likely for their file servers, you see a number of people using NAS, or they are using they are using SAN, which is assigned to a server that is now to use as a shared file server. But what we are particular about here is actually the block storage, the way it works. Now, the two primary protocols for block storage is what we refer to as iSCSI. So SCSI is what I want to remember. In those days for desktop, I don't know if it was using laptop, you used to have this black ribbon with about 40 pins that you used to connect to your hard disk drive. It's called SCSI. Then you have iSCSI. iSCSI is just SCSI across the internet. The I there means internet. So you have iSCSI protocol, and you also have fiber channel. So an example of a SAN storage is you have an EMC box, or you have a Dell Power Edge storage. You have a Barracuda SAN storage. These are SAN storage systems, and what they contain are some of them can be several hundreds of disk drives that are pulled together so that you can break them into virtual disk drives. So I would have my server here connected through internet, Ethernet cable, if I'm using iSCSI, or connected using a fiber channel cable to an EMC switch which is connected to an EMC box. Then I create what I refer to as lawns. These lawns are then assigned to this server. When I assign these lawns to this server, the server sees it as a DAS. That means it sees it as a directly attached disk. But in the real sense, it is not a directly attached disk because the disk is not physically attached to the server. Instead, it is attached across the Ethernet cable or across the fiber channel cable. I hope we get that concept. Hello?
Yes, we do.
Yes, Raj.
Yeah. So that's the major difference. Now, the importance of this within the cloud environment. So you rule out DAS within a cloud environment because you don't have the server, you don't physically, so you can't be using DAS. You'd also rule out NAS, although you'd have something, a service that looks like NAS. But the block storage is one of the storage offerings you have in the cloud. Now, does AWS or Azure have several EMC box that they bought, or maybe from another vendor? We don't know. They could have engineered their own system. They could be using an hyper-converged system because you don't know how they are infrastructure. But the ideology behind the block storage is that you have a block storage as a service, which you can just get and assign to your virtual machine. So you can now begin to imagine, is that they go to the market and begin to buy, say if I say I have 5 terabyte, they go to the market to go and buy 5 terabyte hard disk drive. No, naturally, they wouldn't do that. So they would have gotten a pool of that storage. It could be based on EMC technology. It could be based on proprietary technology that they have designed themselves and begin to allocate them across the network, such that if you spin up a virtual machine now and you want it to have an hard disk drive, that hard disk drive is coming from this storage system using your network. So which means there's a dependency. If the network goes off or probably there's an interruption on the network, that disk drive will disappear from the system, which is a number of things you may have experienced if you work in an environment where they use SAN. You have cases where you would have a system just suddenly losing storage. And you go and check the system. The system has just 2 hard disk drive. But when you log into it, you are seeing about 50 hard disk drive, which means only 2 of them are directly attached. The other 48 are located using a SAN technology, either using iSCSI or probably using fiber channel. Though we may not be able to see that within this demo because we would need to be able to have a storage system somewhere which you don't have. But I would show you how you connect if you are using iSCSI. If you are using fiber channel, then it has to be physical. There has to be a fiber cable connecting your server to the storage system. If you are using iSCSI, all that is needed is just an Ethernet, what's it called? For the storage system to be on the same network where you have the server. Then you can actually use this on every Windows computer system. You have an iSCSI client. You could use the iSCSI client to connect to that particular storage. Then the next is file storage. File storage that allows you see your storage system as a folder or probably a drive that is shared. And there are primarily 2 protocols that manages file storage. You have network file system, which can be used on Windows, but predominantly on Linux. Then you have the server message block, the SMB protocol, which is used, what's it called, within the Windows environment. And this SMB uses, is it port 143 or probably 146? We want to check. Both of them have port numbers they use. I can't remember. So how do you access file storage? You walk into it, // the name of the server, the name of the shared drive. And this is as easy as you just sharing a folder or a drive or one server and accessing it on another server. We'll see how that works once that server comes up. Now, within the cloud environment, file storage is also what you have. You could consume file storage from within the cloud environment. You could consume block storage from within cloud environment. The way the file storage works within cloud environment is still the same way it works. Even if you have that set up locally within your network, you still just work to it like you're accessing a shared resource. But for the block, it's quite different because the underlying technology that drives the block storage system within the cloud is hidden to you, is abstracted from you. So you don't know how they run it. All you just know is that you need a block storage and you see it on your server. And that's what's it called? That's it. So that takes us to identity management. What time do you have here? Okay. So identity management. Let's start this way. Let me see if that server is up because I need to demonstrate that file storage system to drive home a concept within this identity management so that we catch let's see, come back to my server and see if it is up. Guys, up now. Let's go back to the server. Yeah, okay, share. So I'll quickly just take us through the DNS. Then we look at storage and file system. So we had installed DNS earlier. Load. Okay. So we had installed DNS earlier. It's common for you to see this notification on Windows Server when you would have a configuration requirement for a particular role. Now, let me add one more thing on DHCP before we move to DNS. You know, earlier I spoke about rogue DHCP, that you could have an intruder introducing a DHCP server on your network. And what does the intruder need to do? Just get any service. It could be a switch, it could be a router, it could be a server, it could even be a VM on their what's it called? On their own laptop. Connect to your own network, and it begins to give out DHCP broadcast that it's a DHCP server, so that clients that need DHCP IP address can connect to it. But you have a lot of network services having a fix for that, blocking rogue DHCP. You have a number of those features on Cisco router, Cisco switches that will prevent you having a rogue DHCP server on your network. Within Windows Server environment also, there's also a way to prevent that is built inherent. And that's one of the reasons why this guy is looking for complete configuration. Within the Windows Server environments where you use Active Directory, all DHCP server has to be registered with Active Directory. If they are not registered with Active Directory, if they give out IP addresses, if they begin to broadcast IP addresses within the domain environment, the client wouldn't trust it, so they wouldn't take IP address from it. So that means your DHCP server has to be registered. So you can see, okay, this one is talking about DHCP delegation. Because I don't have DHCP here, this is just going to go. But let me come back to DNS. Maybe at that point when we are, I can try to install and make this guy a domain controller and probably see one or two stops. We'll come back to this iSCSI because I spoke about it just a few seconds ago. So for DNS, we said where you have registers of records, and what that records can be, they can be A record, they can be service record and quadruple A record. So for this, the first thing you have is a zone. Your domain namespace, the categorization of your domain namespace, which is your logical family name, is what referred to as zone. And here it says that your domain namespace allows your DNS to be divided into two zones. Each zone stores information about one or more contiguous DNS namespace. So if I have raji.com, it's a zone. I can have a subdomain like maybe lagos.raji.com. It's a subdomain and it's a contiguous namespace because they're actually linked up together. So the first thing I have to do is to create a zone. And in creating a zone, what do? I have to specify. So number one, your zone can be primary, it can be secondary, it can be stop zone. This has to do with you being able to provide more than one DNS server and specify from which DNS server can you begin to have changes. So on which DNS server can I begin to change records? It's primarily going to be my primary DNS server. Then I can have secondary DNS server somewhere. I can have, which is more or less like a backbone or probably to provide highly available service. If you can't reach the primary DNS server for name resolution, you can go to the secondary DNS server where you have a stop DNS server as well. This is you having the domain information for another domain. So if I have a subsidiary, let's assume my company is raji.com. I have a subsidiary, adewale.com. Adewale.com is a separate domain. Naturally, if I have a request, a user that is making requests for adewale.com, maybe he's trying to access a resource, www.adewale.com. I can remember in the last class I asked you to check off authoritative DNS and non-authoritative DNS, right? Did we check it? Hello? Can you hear me?
Yes, Raj.
Yeah. So I asked us to check for authoritative and non-authoritative DNS. So basically, authoritative DNS means that that particular server is responsible for the domain. So it can authoritatively tell you that this name has this IP address. Non-authoritative DNS or probably non-authoritative response basically means that I got it from you from somewhere else, from another server. So I can't vouch for it, or I'm not authoritative to tell you that this is the correct record, but I got it from another server. That is what non-authoritative is. For stop zone, trying to explain what stop zone is in this particular case is if I have a server that is authoritative for raji.com, which is my on-prem DNS server, but I have a subsidiary, which is adewale.com. Then I don't want my client to begin to go through the whole name resolution, recursive and iterative process to get name resolved because I know the exact DNS server for adewale.com. I can create a stop zone here. So, and what that stop zone does is that it gets me a copy of the name server details for adewale.com so that when there's a user within my own domain that needs to resolve information on adewale.com, it just sends it directly to that particular server. Saves time. So I'm creating a primary. I'll call this raji.com. I'll come here. So the register here is stored as a file on this server. And that file is named raji.com.dns. And you can find that file in this directory. System root directory, which is your Windows directory, /32/DNS. There's a folder named DNS. For every zone that I save here, the database is this file. and it's going to be stored in that location. So which means if you delete this file on this server, all your records are gone. So here, dynamic update. What is dynamic update? If a client's IP address changes, you want the client itself to communicate to the DNS server to say, my IP address has changed. And this works in an environment of cloud. It makes sense to have it in an environment where you have DHCP, so that each time a client computer system gets a new IP address from DHCP server, instead of you going to DNS to update it, you could always have the client computer system doing that itself. But mind you, that is where you have endpoints. Your server, you would always want to use a static IP address. So which means if the IP address is changing, dynamic would not work. You have to go and change it, what's it called, yourself. Then I'll go finish. So primarily what I want to show us here is creating a record. So you can see here I have this information, my name service, which is also a record, and I also have my start of authority, which gives me the information about this DNS server. You have this information, time to live. You remember I talked about time to live. For how long should it trust this particular name when you have a name resolution? And you have a whole lot of other refresh interval, retry interval, expires if a client computer system needs to resolve name and needs to validate if that name record is still valid, the number of time it retries before it eventually expires that record. But creating record, yeah, go ahead. Someone wants, you have a question?
Can you please maximize your screen? The window you're on.
Okay, that's.
Thank you.
Okay. So here, I can create an A record. Let me show how I did. I just right-clicked on this. So you can say I have A record, I have I have A record, I have quadruple A record, I have CNAME, I have mail exchange here. So I can come here to say A record. I have www dot, then the IP address is 10.10.10. Second, 10.10.10.1. And this is just a random IP address, but bam, I'm done creating an A record. If I want to create a CNAME record, watch this. For CNAME record, I told you it's name to name. I don't specify an IP address. So I have wants to call this one, maybe I want to call this one web1. I want www.rajiadwali.com to be still accessible using web1. This web1.raji.com. Then I'll say this web1.raji.com is an alias for this guy. For this guy, I'll say okay. So you can see it's a name to name mapping. Web1 mapped to raji.com, while www.com is mapped to 10.10.com. So the two level of resolution is this web1 will first of all resolve to www.raji.com, then www.raji.com will now resolve to
Can anyone stay here, Raji? Because I don't think I can.
Not at all.
Hello? Can you hear me?
Yes, but we lost you for a sec.
Yep. My system just went up. Allow me a few seconds. I want us to finish this. At least let me complete the demo. We are already running beyond the 2-hour time. So let me put up my Spear system. Then we'll complete this demo. Then we'll ask question and we'll call it a day. While that is coming up, if you have questions, any question?
I just observed now that on the DNS that there is actually mail server.
MX
Why
record.
Mail server. What does that one mean?
Mail server.
I just saw it now. Why?
It's actually called
On the
MS record.
DNS when you are saying of
Yeah,
mail server.
That's an MX record that it points to your mail server. If you are being sent an email across the internet, how does the internet routing service know which email server I should send it to? The mail server you were referring to is this MX record. So here I can say mail01. Okay, this is even actually a name to name mapping. So I can say mail01. So let me do it this way. So if I have an Exchange server, let's assume the Exchange server is Exchange 01. And the IP address is 20.10.10. Let's say 17. What I'll publish on my public DNS is an MX record that would say, let me call this email. So let's assume my email system is email.raju.com, and it'll be pointing to this guy, which is my Exchange server. Indirectly, what I'm saying is that if you want to route an email sent to me at setunde@raju.com, you should forward it to this guy. Where this guy, this Exchange 01.raju.com is my Exchange server. That is primarily what MX record is. Then you have what referred to as reverse lookup. The forward lookup zone is mapping of your IP address to your domain name. Sorry, your domain name rather to your IP address. Yeah, domain name to IP address, so that if I say www.raju.com, it gives me my IP address. But you may also want to resolve in the reverse order. That is where you create a reverse lookup zone, where you're saying you want to be able to get a name if you know the IP address. Large number of time, you might not have services that are using this, but after part of email security may require that it creates a reverse lookup zone. So that is pretty much that on DNS. Now, your DNS presently, I said that DNS has the database stored here. When you go to Windows System 32, the DNS folder, and DNS, this is the database. This is the DNS file. This is the database, which is also being backed up here as well. But if I'm using Active Directory, I can choose not to store my DNS in a DNS file, but instead choose to store my DNS in Active Directory that you call an Active Directory integrated zone. But because we're running out of time, we'll come back to identity management. Maybe we'll continue from identity management in the next, session. But let me come to storage and files. Now, if I come to, let me start from here. If I come here to disk management, from here, I can see my directly attached disk or anything that appears like a directly attached disk. So you can see this is disk 0, this is disk 1. They are labeled this way. And one of the things you do with disks is also to choose to partition it and create volumes out of it. So one of the things you may want to check off for this week is difference between partition, although not that naturally important, but it's just good to know. Difference between partition and volumes. Because within a partition, you could have several volumes. So difference between partition and volumes. Then the file system, partition file system. It's in partition file system that you have file system like network file system, that is NTFS. You have resilient file system, which is a new file system for Windows. You have the ext3, ext4, which are file system for Linux. You also have the FAT file system, which is also a Windows file system. So when you are formatting or probably creating a partition, a volume out of a disk, you ask for a file system, but that is just by the way. So if I'm using a SAN, a storage area network, like I said, there are two ways to connect to it. I either use a fiber channel. For fiber channel, it means that on this server, there will be a connection, a fiber connection between the server and the storage system. Or I use iSCSI. If the server and the storage system are communicating using my normal IP network, then in that particular case, I need this client, iSCSI initiator, where I would have to specify what is the IP address of my storage system and which will be the target. Once I specify the IP address of my storage system, it automatically lists to me what are those LUNs. LUNs are logical units of disks that have been taken from a block system and assigned to another system, like a server. Then it will see what are those LUNs that are assigned to me. Once I add those LUNs here, they will come up here as additional disks. That's why I said they would appear like a directly attached disk, because I'll see them here as maybe disk 2, disk 3, disk 4, disk 5, as the case may be. You could use them as the operating system disks for a computer system. You could use them just like you are using this other storage. That is block storage. For file storage, hello, can you hear me?
Yeah,
sir.
continue.
Okay, so for
Yes, sir.
file storage, what I'm having is a storage that is accessible like a file across the network. That's why they are called file storage. So there you'll be talking about maybe sharing a drive or probably sharing a folder. So for instance, if I have here this folder, let me call this repo, and I want it to be accessible, then I'll come here, properties, I could share it directly from there, but come here to say share. I could go ahead here to say share. I'll specify who should be able to access it. Now, that is why I said I want to demonstrate this before we move to Active Directory, which, what's it called? Based on time, maybe that will be our first starting point next week, or probably, I mean, sometimes I may do an office hour video during the week so that we're able to cover it and just move to cloud next week. Now, on this Windows server, right, I have local users. If you come here to tools, computer management, I have users, right? I have server 1. I can go ahead and create another user. I call this guy Aki. I give this guy a password. What password should I give? Call this guy, right? I create password policy. Okay, so I have that user created. I have Akin, right? I could have several users, but the limitation here is that all these users have to log into this system, right, to be able to use the resources here. So which means if I have 50 servers, I would have separate accounts on each of those servers, and users would have to log into this particular servers separately using the account. So I have an account here with a password named Akin. If I have server 2, I have a username and a password also. Maybe name Akin could be the same password, it could be separate password, but the accounts are not the same, right? So which means management of identity.
Sorry, sir. I just want to ask a question under that user on the local server that you just showed us now, the hacking part. I don't know if it's best practice. Is he allowed to create like a user on that server like that? Firstly, I want to ask, if you create a user as hacking, is hacking giving like an administrative right? If hacking mistakenly alters something on the server, does it not spread across all other users?
On that server?
Yes.
Yeah, it impacts that server. If there's a service on that server that I can toys with, it also impacts that service, which may also impact other users.
So is it best
For
practice
instance,
to?
no, it's not. And that's also one of those things I'm driving at.
Okay, sir.
You see, when you do this, one of the challenges is what you have brought up, which is maybe security. And apart from that, the administrative overhead of you having several users across different systems. So if I have 50 servers, every user will have 50 accounts if they have need to access that particular server. That's 50 accounts, which makes no sense. So, but within the context of this now, I'll have these users, right? And when I'm sharing this particular folder, I have to specify who should be able to access it. I can go ahead and specify Akin to say Akin should be able to access this. I'll specify what level of permission Akin has. Maybe read and write. I have the default user here, which is server. I have another. So these are the users that I have on this system. So I'll do this. They will be able to access this server, this folder. And how will they be able to access it? They'll access it across the network. So I would go this way and put this. So I can create. So now this is a shared folder. I can call this test folder 1, and I can put a document on it. So it's coming this way because I'm on the same server, but anybody on the network can just access this folder this way. The server name or the IP address and the folder name. That is how you access what's it called, a file storage, which can be driven either by SMB, server message block, or it is driven by NFS. By default, server message block is default file system that you have on Windows. However, you could also make use of the NFS protocol. So that means you have to install the NFS server or service on this guy. If I come under features, you see NFS, which you can install. But one of the challenges of, now there's no challenge about using shared folder this way. But when it comes to managing who have access to it, also, there's also a challenge. So it means that if I have another,
I'm just sorry that I'm disturbing you on this. I just want to see how it relates to my work environment, and also based on what has been deployed in my work environment, how I can make it better. So in my own work environment, we have like 3 or 4 branches spread across the country. So this particular solution, I use like a NAS for the in-house one in Lagos office. So it's now, we use like a outback solution for it, whereby you only have access based on your own level of let's say your level grid, whereby if you are a
senior staff or junior staff.
Exactly.
Yeah, exactly.
So we deployed that in our Lagos office. Also, we did the same thing for our SharePoint solution. But what I want to now ask is that, is it possible using this this solution you just did now? Is it possible to now do it via Azure? Because Azure is one thing I'm trying to like fully utilize in my work environment. So is it possible to deploy something related to this under Azure that will now be spread across all branches instead of localizing in a particular place?
You have a NAS, right?
Yes.
Which users access across the network.
Yes.
By working to it.
Yes.
And you have the folder.
Yes.
Then you create accounts for each users.
Yes.
Is your account AD?
Yes. I use AD.
Okay, what's it called? It's tied to your AD. Now,
it's tied to my AD, yes.
Exactly. So what you want is, if this particular server or this folder service can be on Azure.
Yes.
Yeah, it's possible. You could use Azure file share.
And people can access it locally.
Yes.
Regardless of where they are.
Exactly. You could use Azure file share. It's possible.
Okay.
So, but that's by the way. So
Okay.
I was saying that this shared folder now is currently on this particular server, and the users also are local on this. So which means if I have another file server somewhere and I share the folder, I have to begin to create those users manually. So it creates a lot of bottleneck when it comes to managing identity. That's one issue. Then also you are not able to track your permissions, because now if I have another server and I create a folder and I give Akin, it means that I've given Akin access to 2 folders under different accounts. So if I need to take off Akin's access, on which one do I know that I'm taking him off and stuff like that? So that's one issue that has to do with identity management, which we are going to address when it comes to using Active Directory. So, but yeah, what I just needed is that you could ask file share as your server message block, using your server message block protocol, which is a default protocol within the Windows environment. And like I said, it could also be NFS, even though NFS is a Linux-based kind of file system. But if you have a Linux file system that you want your server to access, you could always enable this guy, which is a client for NFS, for them to be able to access the Unix-based network file system. NFS is actually called the network file system. Then, if you don't want to be able to manage all your shared folders in silos, like I created one shared folder here, I managed it there. Let's assume there's another storage here. I created a shared folder here, I manage it and stuff like that. You want to be able to centrally manage your shared folders and even begin to define policies like access-based enumeration. For instance, if I do something like this, this guy's name is server 01, right? This is server 01. If I do something like this, is this correct? Is this server 01 or server? Let me check. Properties. Okay, it's just server. So if I just do this without the, if I do this, you can see it's showing me this, telling me that this is a shared folder on this server. So which means if I have more than one, let's assume I have, quickly add this, let's say repo 2, I have this, and I go to say properties, quickly sharing this, I say share, I just say share, go ahead and share done, close. So, and I go to say server this, I can say I have 2, right? Tunde may have access to repo and not have access to repo 2. But when Tunde goes to do this, Tunde sees both of them. But if he opens this, he can see the content and can save to it depending on level of permission defined. But when he goes here, it only throws an error. But I want a situation whereby Tunde is only able to see what he has access to. So he doesn't even know what are the shared folder or probably repositories that I have within the system. So you want to be able to have that granular level of permission, or even in some environments where you want to be able to manage what type of files user stores here. Like I've seen a situation where is that what's it called? Reported told me that their users are just using up their shared file system repo. They download movies, they don't want to put it on their system, they just dump it there and stuff like that. You want to be able to manage what type of files users can place on this folder. Then you may want to, instead of just managing this manually, you want to install and use the File Server Resource Manager. File Server Resource Manager allows you to do more when it comes to managing files. So I have this File Server Resource Manager, which you can install and can help you to do stuff like file screening, quota. You can specify quota per department or probably per folder. How much, you can see my storage here is 117 gig. If I want to say, no matter what they store on this repo, it shouldn't do more than 50 gig, then I have to define a quota. That would allow me. While the screening is you specifying what type of files is allowed on that system. So you can do that at this particular level here, but not much of that is actually possible for a number of services you have in Azure. So, but just have it at the back of your mind that you have this service within the Windows Server system, and you could make use of it. So this guy is done. If I just quickly connect to File Server Resource Manager, from here I can define quota, I can define file screening, I can generate a report that will give me what are the most common types of files that I have within my environment, and who is the largest file user and stuff like that. For instance, if I want to specify a quota for that my repo, come here, select this repo 2. I'll say this repo 2, and I want to specify what will be the limit. The limit should be, I have templates, or I could create custom 2 gig limit. So it's going to notify at 85. It will also notify at 95 and also create an event log. And that is it. And if it is file screening also, I want to specify what type of files that I want. Here, I want to go here to say on this guy, I don't want, I want to block audio and video files. I want to block executables. So I'll block audio and video files, and you must specify one group. I thought I did this. Yep. And that is that. So that's that for file system. So we'll take it off from here. Next class, or probably within the week, if I can just create the content and share with you so that we understand before we move. I want us by next week to now really get started within the cloud. But if you have questions within the next few, what's the time? Yes, this is only the next 5 minutes. Question or clarity? Something you want us to clear? Let's do
Okay.
the next 5 minutes.
We are just going to start on cloud security on Azure by next week, Shay.
Cloud would be everything about cloud, including the security operations.
On Azure by next week. Is that what you want?
Yeah.
That's
okay. Exactly. That's correct.
Okay.
So any question? So if we have no questions, we'll call it another week. Activities for this week I would share with us via email and also through the Discord channel. And like I also said, I could do a number of short videos during the week to explain it, especially that Active Directory or Active Directory and also PowerShell. I wish we were able to cover the basics of what's it called, PowerShell, before we now feed forward those knowledge to next week. And if you have questions, also things you need to clarify within a week, you just drop it in that Discord. Myself or probably another person who is able to help can always jump on it and work on it. So for activities, by the end of today or probably tomorrow, I would share that with us. So I would want us to complete it. As you complete it, to share the other guys up also. To just share it within the channel. And also if you have challenges, you could also drop it within the channel. If you have questions also that you also want others to learn from, just drop it there. We'll all try to respond to it. So
okay,
that's
Roger.
all for
Thanks a lot.
today. Yeah, welcome. Enjoy the rest of the week.
All right. You too.
Thank you so much, sir. Thank you, sir.
Thank you so much.
Thank you very much, sir. Thank you. We really appreciate the opportunity. Thank you very much.
Thank you very much. All right.
You're welcome. Yes.